Okay, problem 1 on the study guide. Find the range, median, mode, and the mean of the following numbers. The first thing I would do, if I'm asked to find median, which we're going to be asked, is to take the numbers, put them in numerical order, smallest to largest. And we got 10 happening twice, and then 15, then 21, and then 22. Make sure all the 5 numbers, you counted 5 numbers there, 5 numbers here, they're in numerical order. So first off, range is the biggest minus the smallest. So 22 minus 10 is equal to 12. The median is the middle. So we've got 2 here, 2 here. This is the middle. The mode is the number that happens the most. 10 happens twice, everything else happens once. Keep in mind, if there's multiple numbers that happen the most, then they're all the modes. So if it was 10, 10, 15, 15, 22 maybe, then 10 and 15 will both be the mode. In this case, just the mode is 10. And as far as means concerned, we have to add them up and divide. So if I add 10 plus 10 plus 15 plus 21 plus 22, there's 5 numbers altogether, so we divide by 5. That's 35, 36, 56, 58, 78. Then we divide 78 by 5. So 15.6 is the mean. And you'll notice the box has all these things identified, so make sure you put things where they belong. Range, median, mode, and mean, all identified. Number 2, convert 13,000 square inches to square kilometers. And the path I'm going to go is inches to centimeters to meters to kilometers. And we know facts about all these things. They're on our formula sheet you'll get to use during the test. 13,000 square inches goes over 1. And keep in mind, inches squared, 13,000 is not. So 13,000 happens once, it's inches, inches. If I'm going to go from inches to centimeters, the fact about inches and centimeters is 1 inch equals 2.54 centimeters. Inches is in the denominator for cancellation purposes, 1 on top, 1 on bottom. There's 2 of them, so I got to do it twice. So this cancels this. This cancels this. I'm at centimeters, centimeters. Next thing I want to do is go from centimeters to meters. And the fact about that is that 1 meter is equal to 100 centimeters. And again, based on location, centimeters is in the numerator. I need 1 in the denominator for cancellation purposes. I got to do that twice. 1 meter, 100 centimeters. That's going to work with that. So cancel, 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 cancel. Now we're meters, meters. And the final thing I want to do is go from meters to kilometers, and 1 kilometer is equal to 1,000 meters. 1 meter on top, 1 meter on the bottom cancels. I got to do a second one. That cancels that. And that gets me here. And once I get all the way there, I can see where the numbers are, and where they are determines how I'm going to type in my calculator. So I'm going to do 13,000 times 2.54 times 2.54 divided by 100 divided by 100 divided by 1,000 divided by 1,000. Every number on the bottom you hit a divided by, every number on top you hit a times in your calculator. That's how your calculator knows how to work. So I just type it in exactly like that, 13,000 times 2.54 times 2.54 divided by 100 divided by 100 divided by 1,000 divided by 1,000. Verify everything's typed in correctly. It equals, and it comes out to 8.38708 e negative 6. Okay. Know how your calculator displays things. This is a scientific notation structure. That's how my calculator displays scientific notation. What it truly means is 8.3 39 times 10 to the negative 6th power. That's going to be kilometers squared. Okay. Don't give me that result. Give me what it really means. The other option would be 0.00000839 kilometers squared. We're writing in decimal notation. We haven't actually dealt with scientific notation yet, so I would probably stick with just the scientific notation look that my calculator gave me for that one. Number 3, the perimeter of a rectangle is 42 inches. The width is 9 inches. Find the area of the rectangle. So if we have a rectangle, first thing I'm going to do is draw a rectangle. I put down facts about the rectangle that I know. The width is 9 inches. The length I don't know. The perimeter is 42. So add up all those numbers, you get 42. The question they're asking me is to find the area of the rectangle. Area is length times width. I can't answer that question without knowing what the length is. So job 1 is to find the length. So I know that 9 plus L plus 9 plus L should equal the perimeter. Again, I just drew the rectangle. I know these two sides. I don't know those two sides. I'm just going to let algebra work for me here. If I combine like terms, 2L plus 18 equals 42. Move the 18 over, I get 2L equals 24, which means L, of course, would be 12 inches. Verify if you want. 12 plus 9 is 21, plus 9 is 30, plus 12 is 42. The correct perimeter comes out with that dimension. The area of the rectangle is what we're asked to find. Area of a rectangle is length times width. So the area of this rectangle will be 108 inches squared. Moving on to number 4, what percent of 170 is 23? Some percent of some number is some number. Immediately gets me to the percent proportion. Percent proportion, always start with the percent. It says what percent, which means we don't know. I'm going to put X right there. And then over here we have is over of. Okay, there's of, there's is. And looking at is, both numbers 23 and 170 are next to is. So is could be either one of those numbers. But if I look at of, the only thing next to of is 170, because we've already used the what percent. So the only thing that could be the bottom number is 170. And once we use 170, the only thing left to be on top could be 23. So again, create the proportion correctly, and then solve the proportion based on what you've got written down there. So if I cross multiply, 170x is equal to 23 times 100. Divide both sides by 170. And I don't know what that is off the top of my head, so I'm going to use my calculator. 2,300 divided by 170 comes out to 13.53%. I'm fine with a couple decimal places whenever you get a decimal answer, so you can write as many as you want, but the percent that you're getting is an actual percent. It's going to have the right decimal wherever it's at. So again, 529, I went 53. Number 5. If 30 is increased by 130%, what is the result? Okay, this is the other percent type of problem that we've seen recently. Remember, let's pull this down a little bit. It's always percent of something, and there's an implied of 30 because whatever this number is what that is. So if I just write a basic algebra statement out of this, 30 is increased by 130% of 30 equals the result. Right. 30 is being increased by 130% of 30. And that's how we write it out. And then it's just a matter of working it out. And at this point I can just actually type that expression right there in my calculator. So 30 plus 130 divided by 100 times 30 equals, and my calculator tells me it's 69. Alright, so number 4, simple percent proportion. Number 5, you have to create an equation. Again, percent of itself. So if this is 70, this is going to be 130, 100 times 70. So that's just how it works. Number 6, write 900 as a product of prime factors. Rather large number, but really simple start. 9 times 100. And just by doing that, it gets us down to a pretty reasonable level. 9 is 3 times 3. 100 is, I'm going to go 4 times 25. 10 times 10 works also. 3 is already prime. Can't do anything to it. 4 is still composite. It's 2 times 2. 25 is 5 times 5. And just like that, we get the prime factorization there. If you want to write it like that, that's fine. 2 squared times 3 squared times 5 squared is my preferred way of writing it, but I'm fine with both ways. So give me the correct answer, all prime numbers, and the product of those numbers should be 900. Number 7, h of x equals 1 over x, find h of 5. It is that easy, it will be that easy on the test. Please don't miss that problem. That's x, change that to 5. I don't know. That's the problem that tells me whether or not you're prepared for the test. So, number 8, x plus 5 equals 11, find the value of x squared minus 11. The value of x squared minus 11, I need to know what x equals to do that. Over here I have an equation that tells me how to find x. X plus 5 equals 11. Find the other side to change the signs. I'm going to get x equals 6. Once I know x equals 6, I'm going to go right there and change x to 6. 6 is being squared. 6 squared is 36. Officially, it's in parentheses, 6 squared. If that was a negative number, the negative would be in parentheses also. Be careful of that. 6 squared is positive 36 minus 11 equals 25. So, use the equation to find x. Use x to find the value. Evaluate correctly by the order of operations. Number 9, least common multiple of 13, 14, and 15. What I want is a prime factorization of each of these numbers. 13 is prime, so I can't do anything to that. 14 is 2 times 7, both to the first power. 15 is 3 times 5, both to the first power. And the least common multiple is simply every single prime number that occurs over there to its highest power. And as you can see, they're all different. So 2 times 3 times 5 times 7 times 13, all to the first power. And we just multiply those out, whatever it comes out to. 2 times 3 times 5 times 7 times 13 comes out to 2,740. If a number happens to repeat, let's say that this is 3 times 1, let's say times 2 squared, let's say that this last number was 60 instead of 15, then still 2 happens, but now we're going to take the second power instead of the first power. 5,460 would be the right answer then. So keep that in mind. I'm not sure that the numbers will be like this, where they're all just a bunch of different primes here. So it could be where the same number happens multiple times. Write it once, highest power counts. Number 10, add. We're adding fractions. We can't add fractions without a common denominator. Looking at the denominators of 3, 5, and 10, I'm seeing 150. How about 30? 30 is the least common denominator. So if I want to find the least common denominator, it's just a matter of doing the factoring again. So we got 3 to the first, we got 5 to the first, we got 2 to the first times 5 to the first. Least common multiple is 2 times 3 times 5. First, first, and first. And 5 happens multiple times, but 1's the highest power. So the least common multiple of the denominators is 30, so the least common denominator is 30. And then what my recommendation is with fractions, always just make one big fraction bar, and then just fix each fraction individually. So this, 3 is what it was, 30 is what it is now, that's times 10, so 2 times 10. Second one, 5 is what it was, now it's 35 times 6 is 30, so 3 times 6 is 18. That's being added. 10 is what it was, 30 is what it is now, 10 times 3 is 30, 1 times 3 is 3. Again, it's plus, 1 times 3 is 3. And then once you get all the numerators correct, then it's just a matter of adding them up. 30 is the denominator, 20 and 18 is 38, plus 3 is 41. So 41/30 is the sum of the 3 fractions there. Number 11, add these polynomials, write the answer in descending order of variables. Some of you aren't doing this part. getting the right answer, but you're just putting in whatever order. Descending order means the highest power of x down to the lowest power of x. We have cubed, we have squared, and we have constant. That's the order of descending rank. 3 is the highest power, 2 is the next highest power, constant's the least power. And when I do this, I'm going to add up 3x squared plus, 3x cubed plus 4x squared. And usually you leave a gap because there's no x term, so I'm going to leave a gap plus 7. There's my original one. There's nothing in front of this creating anything new, so the parentheses are there for effect only. They're not there for any purpose other than just to separate the two polynomials from each other. Then I'm going to line up like terms in the second one again, plus the second one, so the parentheses aren't there for any reason, just to set off that polynomial is a different polynomial than this one. 4x cubed, which is being added, 3x squared, which is being added, and 5, which is being added. If there were any minuses, minuses would show up there. And when you go to make the decision, should I add or subtract, it's based on signs. Obviously, the signs are the same in everything, so we're just going to be adding everything, making the answer positive. So 3 and 4 makes 7x cubed, 4 and 3 makes 7x squared, 5 and 7 make plus 12. X cubed, x squared constant, that's descending order. If you give me those 3 terms in some different order, and it is asked in descending order, you'll lose half credit. So be sure the powers are descending, third power, second power, constant. That's what descending order of the variable means. Number 12, simplify. We've seen these now for about 6 or 7 tests, it seems like. We have 3 terms. They're all even. Divide everything by 2. So 2 divided by 2 is 1. 8x divided by 2 is 4x. 2 divided by 2 is 1. The 1 plus is required. The divided by 1 isn't. So divided by 1 doesn't change anything. Plus 1 does change things, so that plus 1 is necessary. Don't forget about the 1 there. Number 13, simplify. We got negative powers, 0 powers. We got x's and y's all over the place. So our first priority that I've told you to deal with is the negative and 0 powers. So the first thing I'd focus on would be this, and this, and this. Everything else would just come along for the ride. So what I would do, my first step, I'd rewrite x to the first and y to the fourth on top, rewrite x cubed, x to the first, and y cubed on the bottom. Notice I put first powers there just to remind myself there's powers there. Sometimes we forget. So this, and this all stay where they were. The 3 things I have highlighted in blue are going to either move or go away. This x to the negative 7th belongs on the bottom. That y to the negative 6 belongs on the top. And x to the 0 power equals 1. Times 1 doesn't do anything, so I can just strike that one out. So step 1 done. At this point now I've just got a bunch of letters to positive powers in the right locations. The next thing I'm going to focus on is the same letter occurring on the top and or bottom. So these are the same letter on top, and these are the same letter on the bottom. The x on top and the y on the bottom are not affected by this at all. So I would just bring those over. So x to the first is staying on top, and y to the third is staying on the bottom. I'm going to get an xy order on top and bottom, so I'm just going to go ahead and put the y cubed over here a little bit. As far as the stuff I have highlighted, for y on top, I'm going to add the powers. 4 plus 6 is 10. For the x's on the bottom, I do the same thing, add the powers. 3 plus 1 is 4, plus 7 is 11. Okay. I'm not worried about anything except for what I have highlighted when I do that step. The final step is division, and if I have the same letter occurring on top and bottom, I've got to deal with that. So those are the same, and those are the same. So I'm going to get x to some power and y to some power. And I have a fraction bar here. I'm going to put the fraction bar right there. The 2 decisions you have to make, decision 1 is where does it belong, decision 2, what is the power. Where it belongs is based on the higher power. So 1 and 11, 11 is higher, it's on the bottom, that's where x belongs. Subtract big minus small to get the power that it should be. For y, 10 and 3 are my powers, 10 is bigger, it's on top, that's where y belongs. 10 minus 3, big minus small power gets me 7. Once I have 1x, 1y positive powers, I'm done. I circle my final answer. There are no negative powers in final answers on these problems. Please always make the negative powers go away immediately and then just put everything where it belongs correctly. All powers stay positive from that point forward. 14, find the area of the shaded portion of the trapezoid. Dimensions are in feet. It doesn't say it, but angles look like right angles are right angles, so this is a right angle, this is a right angle, this is a right angle. So, I have to find the area of the trapezoid, subtract the area of the triangle, that's all I have to do. Area formula for trapezoid is 1/2 times the height, which is 13, times the sum of the bases. And the bases are 15 and 19, and that's the sum of the bases, so add those up. 15 plus 19 is 34. It's a very easy formula to remember. Area formula for triangles: half times base times height. Trapezoid's half times the sum of bases times height, so it's almost the same formula. And then if I just multiply that out, 221, I think. 0.5 times 13 times 34, 221. Perfect. Okay, the area of trapezoid is 221. As far as the triangle is concerned, area of a triangle is 1/2 times its base times its height, and the base and height are perpendicular to one another, so 6 and 8. It's 1/2 times base times height. Half of 8 is 4 times 6 is 24. And again, the shaded portion is just the trapezoid, 221, minus the triangle, 24. So 221 minus 24 is equal to 197. Dimensions are in feet, so that's going to be square feet. Alright, so expect on the test to define a trapezoid with a triangle being cut out. Find the trapezoid, find the triangle. Both of these formulas are on your formula sheet that you get to use during the test. Finally, number 15. Once again, I forgot something on the question. These sides should be marked as equal. They aren't, but they will be on the test. So make sure that you identify those as equal. When sides are equal, an isosceles triangle, the angles opposite the sides, which would be y and x in this case, are going to be equal to each other. So I know x and y are equal to each other. I also know if I do 180 minus 132, I've got 48 degrees left. 48 degrees remain in this triangle. X and y make up the two angles I don't know. They're equal to each other. They have to add up to 48. So x and y both have to equal 24 degrees. Again, on the test, you're going to have the same picture, different number here, obviously. These will be marked equal. You'll be asked to find x and y. So determine how many degrees are left. Divide that number by 2. 24 goes there, 24 goes there, makes 48 total, and they're equal to each other that way. So it shouldn't be a very difficult final problem on the test, hopefully, for everybody.